morning, ladies and gentlemen. I would like to quickly introduce myself. My name is Lou Chenjie, and I am a student of Institute of Information Engineering, Chinese Academy of Sciences. Today, I would like to share with you our work, a novel adversarial example detection method for malicious PDFs using multiple mutated classifiers. My talk this morning is divided into 4 main sections: motivation, background, methodology, experiments, and analysis. First, I'm going to present the motivation for working. I think you all know that deep learning and especially DNN have emerged as one of the primary techniques in academic communities as well as industries. They bring great convenience to technology and people's life, but it also brings safety concerns. These systems have been shown to be vulnerable to adversarial environments with novel evasion attacks. The issue triggered a broad interest in researchers in detecting or defending against adversarial example. In computer vision, methods have been proposed to improve the robustness of the DNN model. Though able to detect adversarial malicious PDFs from massive PDF files, it poses a big challenge to the forensic investigators as well. Next, I will introduce a little background of the research and the knowledge needed. Let's start with a quick look at the basic concepts on portable document format, PDF. The structure of a PDF document consists of 4 parts: header, body, cross-reference table, and trailer. As shown in the figure, the body specifies the content of the PDF and contains text blocks, fonts, images, and metadata regarding the file itself. It contains a set of PDF objects that constitute the content of the document. The attack is usually achieved by modifying the body and the cross-reference table. Supervised machine learning has been widely deployed for malware detection. Concerning PDF files, multiple detectors were developed in the last decade that implemented such technology. The primary goal of machine learning detectors for malicious document detection is to decide whether some unseen PDFs should be labeled as malicious or benign. In general, their structure is shown as in the figure, which is composed of 3 main parts: pre-processing, feature extraction, and classifier. Adversarial attacks on document detection systems are also called the evasion attacks. They take advantage of knowledge of how the machine learning system operates and utilize access to the training set of features to evade detection skillfully. Like image adversarial example, document adversarial example can be generated using 2 major approaches: content-based approach and feature space-based approach. The former mainly includes mimicry, reverse mimicry, and flawed documents. while the latter is represented by gradient descent attack and evade ML attack. One immediate stranger to defend against adversarial example is adversarial training, but it can only be used to reinforce existing systems. There are also ways to deal with adversarial example in terms of document detection, such as ensemble classifier, mutual agreement and license, robust feature, document entropy time series. Unfortunately, they all have fatal shortcomings. Then I will share with you our methodology. In response to above challenges, we propose a detection method based on one essential attribute of adversarial example. It is that existing adversarial examples are usually generated for certain model, and even if affected by transferability, adversarial examples are likely to fail on another similar model. Our approach finds these models to eliminate the effects of transferability. Then we use the prediction inconsistency of each model to get the detection results. It also depends on the reinforcement design of the detection system. Next, I introduce the two main methods and the final detection system in turn. The first main method is mutation model generation. We take a similar string as in the fuzzing to generate a detection model group. In other words, the training parameters of some normal machine learning models can be adjusted to generate similar mutation models. It contains 3 key points. 1. Use 6 basic models commonly used in malware detection, include SVM, KN, native Bayes, logistic regression, decision tree, and random forest. And second, explore and test the corresponding mutation operators. Last one is selection of models. The first two are to ensure smooth model generation, and the selection of model is strongly related to the second method. After the generation of detection model group, the next step is to input the testing examples into the models sequentially and record the prediction results of each model. Then we will calculate the prediction inversion rate, PIR, and compare it with the benign examples to determine. The principle of detection using PIR is shown in figure. When a benign example enters the original model, the prediction is benign, 0. The prediction reverses if the model in the detection model group classifies the input as malicious, 1. And the same change occurs when the input is an adversarial example. We can calculate PIR from the number of models that have reversed and find that the adversarial example is more sensitive to the model. 2 points need to be noted. The first is that the PIR calculation module needs to support the calculation of benign example. And the second is to set the adjustment factor of threshold. Based on the above modules, we redesigned the detection system based on machine learning model. The whole structure is relatively clear. The three parts of the detection model were repaired in the pre-processing stage of machine learning methods. Example filtering of flawed documents and mimicry attack is added. In the subsequent features extraction part, we mainly use two types of effective feature sets: content-based features and structure-based features. To ensure that the detection results are reliable when generating the final classifier, we first need to train an original model and ensure satisfactory performance. Then generate a series of models for calculating PIR based on the detection model group generation algorithm. And the PIR calculation module was added after the classify. Finally, I will analyze the experimental results. The collection of data sets, experimental settings, and evolution indicators can be reviewed in the paper, which will not be described here. You can see Table 1 lists the indicators of the original model. The detection performance of the model is very high in the case of using integrated features. Based on its performance, the final generated model group contains 700 models. As the Table 2 records the mean PIR values of all examples of each type. It can be seen from the table that the PIR of a benign example is significantly less than the PIR of any adversarial example. This table records the results of the comparative experiment. Our system can effectively detect adversarial examples generated by faulty attacks. I think there are three main reasons. First, we used comprehensive features when training the model. Second, we added the state-of-the-art parsing method and pruning algorithm in early stage. Most importantly, PIR points out the essential flaws of the adversarial example. In addition, our system is slightly higher in average detection time than other detectors. The main reason is the existence of non-optional modules. That's all for my introduction. Thank you for listening. If you have any questions, please don't be hesitate.